Hello everyone, so welcome to data science sketch. So in this course or in this lecture, what we're going to be talking about is Numpy. So for those of you that are a bit more familiar with Python, Numpy is a module that allows you to kind of like create matrices of data and make calculations and access data in different ways. It's a really powerful tool. And I think every data scientist, every machine learning enthusiast needs, or whoever wants to do data science needs to know about NumPy, right? So let's dive into it. Alright, so let's start here. Let's start here with arrays. So basics of arrays. Array is some sort of like matrices that you can define using NumPy. So in Python you would do import NumPy module as np over this cloud here, and then you could use this function. So you can write and say you can define an array and say some variable x is equal to np that we have loaded here dot array. Array, right? And then how do you define it? You say open some brackets here, and then you pass in a list of values. So let's say I pass in these values here. 5. Close the bracket. And then, so in the function np.array, you pass in bracket some numerical data, some values into this square bracket, right? And this one is a way to define or to create a matrix. And the output of this, so allow me to use two arrows as a sign to indicate what the output is going to be. And the output here, Python will give you something like this. And then Python will show you this. So maybe you were successful in creating beautiful. So, and then something that is really interesting is that this is a vector that you have, right? So you do have a vector that is holding or a 1D, let's call it like that. It's a one dimension sort of matrix, right? Because you have data in one dimension. If we had data in 2 dimensions, say we did have 1, 4, 3, 5 like this, that would have been in 2 dimensions. But let me not get ahead of myself, because we are definitely gonna go and touch upon that. Okay, so we've defined this here, right? And then something that is also interesting is that we could create array from scratch, because what we've done here, we've defined explicitly what the numbers are, right? But we could define array from scratch, and then you could say give me x, and I want an array that only has zeros in it, and like I want it to be, I want about, let's say, 5 values. And then you can define a type. You can say I want the type, to be an integer. All right, so what is this going to do? Basically, this is going to create the following. So let's go and show. It's going to create an array and then it's going to give you 5 zeros. All right. Beautiful. All right, so this is what you've got here. This is a way to define a matrix, or a 1D matrix, or 1D vector, you could call it, with zeros in it. Now you could do the following. You could do, let's define even x here and say x could be equal maybe to np ones. So here, if you can guess it, we are defining, let's do something here. Let's come to the 2D matrix. What we are defining here, we can say np.ones already tells us that we want an array that only has 1 into it, like values of 1. And then you can come here and you can say, okay, put a parenthesis and say I want an array with 2 rows and 3 columns, right? This is what I want. And we can do this, right? Or we could also add the D type, right? But I'm gonna skip it now here. And we can go and say, and then what Python is gonna give you. So let me say something interesting. So as you come and define it this way, so let's say you're in Python and you define it this way, right? You're not gonna have the output this. The output is gonna come only if you write X and then you press and then you run it. Then Python is gonna show you this output in array here. But I really go and I'll show to you guys what I mean. But let's move forward here. And then here, what would you get? You get an array, right? And then you would get the following. You get the first row, 1, 1, right? And then this is closed. Then you have another row again, 1, 1, closing here. So you have another one here, another one here, and then you close here. All right, so this is what Python, oh, sorry, my bad. This is what Python is going to give you as an array. So let's go ahead and let's try it in Colab. All right, so here, this is a Jupyter notebook that we have. If you guys are more familiar with it, it's Google Colab, Collaboratory. It's a Jupyter notebook hosted in some Google server. And it's really easy for prototyping. Anybody can, with a browser and internet account, can open the website, create an account basically, or whether it's Gmail or Google, can easily start using Colab. So by doing that, what you do, you come down. Let's start actually. All right, let's start putting in practice what we've learned. So say, for example, we want to define the array. We can say X is equal to NP array. And then we come down here and then we define what we want. We can say we want 1, 3, 5, and 6. And if I click Control Enter, I'm running the script here. And something that you will see that by running this alone, we're not seeing the output coming out, right? I need to tell Python that I want to see this one. And then if I come in and run this, then as you can see, we see the array, right? So we get array 1, 3, 5, 6. So this is a 1D vector or 1D matrix, as we said here, or as we did it here. Right? Okay, so now let's come and do this one here. Okay, so let's create a matrix of zeros. Let's say now let's let's insert a new code cell down here, and here you can come and say, let's even skip the X and let's define an array here. Sorry, np array, and then let's say here, sorry for that, I want np those zeros. If I do this, you get an error, right? Because you need to define how many you want. So if I put 5 here and I do this, then you can see we get this right here. So we get an array, as we mentioned it here, right? An array with 5 zeros. Here I defined the type, which is an integer, but it wasn't really necessary, right? But again, okay. And then now let's go with np.ones. So you can create matrices of ones. As we said there, we are going to say we want it to be two rows, 3 columns. If we run this, there you go. We get 2 rows and 3 columns. Wait a minute. Here we said 2, 3. Sorry. So here, I made a quick mistake. So it's supposed to be 3 columns. I got myself. Okay. So here you get 3 columns. You can see the mistakes are pretty much everywhere. It's easy to make mistake, but yeah, you get 3 columns, right? And this is what we got here. Beautiful. So as you can see, it is really straightforward and simple to create arrays, to create matrices. And let's go ahead and do something else. So we can create also arrays in other ways, right? And this is what we're going to do now. What you could also define, you could say, let's do something. All right. So what you could also define, you could say, for example, let's come in somewhere here, and you could say the color here, and we can create an array in a different way. Say, for example, you can use something, we can say np dot arrange. So you can say that you can use the attribute arrange. The attribute arrange, you can pass in what do you want, right? You could the sequence. So let's say, for example, if I want 6, if I put 6 here, I'm telling that I want a sequence of numbers that go all the way to 6. Right? A sequence of numbers that goes all the way to 6. And if I do this, guess what is going to happen? This time around, you can actually go live and you can say np.arrange. And if I put 6 here, you can see that we're going to have a vector that goes all the way to 6. You see 0, 1, 2, 3, 4, 5, right? So it means I want a vector that goes from 0 to 6, but it's not really the number 6. How many integers, how many values do I want going to 6? So this is what we got. Let me even reduce the number here so I don't have to draw a lot. So if I put 3, this means that I'm getting, as a result, an array that has the first number, the second number, and the third number, because I specified that I want 3 numbers here. So here I specified that I want 3 numbers. So you have 1, 2, 3, right? So it's not that it's going to count all the way towards 3, but it's just that it's giving me 3 numbers. Something else that I could have done, let's delete this. And let's say here that we want to go from 0. We want to go from 0 to 6, for example, and we want to go in steps of 2, for example. So what is going to happen here, if you guess it, it's going to give us an array, obviously, but that start with 0, that goes to 2, because we said we want steps of 2. So 0, normally it's 0, 1, 2, so we're skipping 1, 2, 3, 4, we're skipping 3, then 4, 5, 6, we skipping 5. So then we have 6 here. All right. This is another way to define an array, right? So np.arrange. So what it does basically gives you a linear sequence. Of numbers that is starting. So starting point is this one. Ending point, it's a 6, right? And then the step is 2, right? So this is what is happening here. Okay. Sorry to do. All right, guys. So far so good, right? Now let's go ahead and do something else. What we could also do, we could create an array for something similar but not quite the same. We could use line space. And bit of line space. Oh, it's not really line. Sorry for that. Actually, let me quickly fix this. All right, it's not line space, it's line space. So a linear sequence or linear spacing. If you do that and say, I want a linear spacing or linear sequence, starting from 0 to, let's say, 1, and I want to have 5 numbers. Right here now, no more, it's not stepping anymore, but in this particular case here, what you will get is an array. And then you start with 0, obviously. Then you can get, say for example, you say stepping towards 5 and in 5, right? So you can get 0.25, then you get 0.5, then you get 0.75, then you go to 1, right? So then what you've done here is that you want linear values that go from 0 to 1, but you want 5 values. And if you count, you have 1 here, 2 here, 3, 4, 5. Beautiful. That's what you wanted. And I think it's time to go and test this one. So let's go and test linear space. So you can do NP. Let's even bring a new one here. Set a new code cell. Say np.line space. And let's come here and let's say I want it from 0 to 1. And I want this in 5 steps. If you run this, quick mistake here in space. If you run this, then beautiful, we get what we expected to get, right? We can play around with it and say I want 6 numbers. Say for example 6 here. Then if I run this, then I get 6 numbers, right? Beautiful. So this is really, really nice, and it's going to be really, really helpful for you guys that end up working in problems where you need to create some sort of data right? This function is really, or this attribute of numpy is really, really important. Right, this is really, really important. All right, so let's move on, right? Let's move on now and start creating random numbers. So you could technically create or generate random numbers. All right, so maybe this isn't the right thing. Let me do this. All right, so what we could do, we could generate random numbers. Wonderful. So let's come down here and say, how do we do that? We could use the function or the expression np dot random, right? By saying that, it means we want random numbers. Now, the attribute that comes afterwards could be random. You could also use something like normal, or you could use something like rand int, which works fine as well. So let's start with random here. So what random here does, let me take this right here. What random here does is it gives you random values, basically, right? And it gives you random values that go between 0 and 1. So let's say you flip a coin between 0 and 1, you could get 0 0.5, 0 0.23, 0 0.16, 0 0.97, 0 0.56, right? So it really, really doesn't matter. It gives you literally a coin flip, right? So you flip a coin in the air, it gives you, it's like random values. Sorry for my drawing, but okay, you get a point. All right, let's get rid of this. On the other end, the normal one gives you random numbers in this distribution, a mean of 0 and standard deviation of 1. Right? So what it's gonna do, it's gonna sample data from this distribution. From the distribution right here. So as you sample it, basically you can see that data that are in this shadowed region here would have more tendency to be picked as opposed to data that is, let's say, somewhere here, right? This is how it works, because those guys have less probability of occurrence, right? The majority of the distribution is clustered around here. So data that is here in this zone here will have more tendency to be picked up rather than, so let's say the guys that are in this side here, right? So any value close to 0 will be most likely picked up. The one that is far away from 0, to the far away you go from 0 towards 1, the less likely they are to be picked up by this random random number generator and p.random.normal. All right, so let's clean a little bit this mess that I made here. All right, so we're getting there. Let's clean this one a little bit. Okay, so, and then basically you need to define what is it that you want, right? So you could pass in anywhere between, let's say random, if you pass in to this tells us that we want basically a matrix with 2 rows and 2 columns, let's say, for example, and random normal, the same thing. Here you need to define, however, what is it? You need to define the mean of distribution, the standard deviation. Then from there, now you can say, okay, what sort of data you want. So here you can come and say maybe 2 and 2, right? And then random integer. In here, for example, you can define what integer you want. So you can say, let's say from 0 to 10 is what we want. Then we can come here and say a 2 by 2 matrix as well, right? So say this one is a number 1, this one is a number 1, number 2, and number 3. And what are we going to get? For number 1, we are most likely going to get an array of the following, let's say 0.56, 0.13, right? And then you get 0.78, maybe. These are random value, right, that I'm generating at the moment. 0.46 of, and let's say 45. Put this one here, right? This is sort of array we're getting for number 1. For number 2, it's a normal distribution between 0 and 1 basically. So you could get, let's say, minus 0.06, 0.71, and then you can get 0.29 and 0.11, let's say, for example. As you can see, the data will never get higher than 1 nor smaller than -1. And then the third one could be something like 0 to 10 could have 5, a 4, 6, 7, and 3. All right, and then this one is number 1, this one is number 2, and this one here is number 3. All right, so there you go. There you have it. Right, how to generate random numbers with Numpy. And let me just turn the color here. Doing this live. Okay, so beautiful. All right, so we're able to know how to generate random numbers in Numpy, and this is pretty nice. All right, so this is the first part. Now let's go towards something a bit more interesting.